solving quadratics by factoring. Solving quadratics by factoring. Okay, so again, that kind of order of the way of doing things. Kind of have to have something done first. Y'all remember this from Algebra 1. What does the equation have to be equal to before we can do any factoring? Has to be equal to 0 first. Before you can do any factoring, your equation has to be equal to 0. If it's not equal to 0, then you can't do any factoring yet. So got to get the equation equal to 0 first, and then that opens up all of the things to do with factoring, which the first thing that you wanted to do was make sure it's in descending order by exponents, highest exponent first and go down, left to right, and then we look for greatest common factor, and then we count terms so that it helps us know what method to try to use. If there are 4 terms, what method did we try to use? Grouping. And a lot of times, it wasn't necessarily grouping at the beginning. We turned it into grouping because it had a trinomial, which was 3 terms, and that's where we're using that X method. And then if there were 2 terms, most of the time we're going to be dealing with differences of squares right now. But understand that later on there's a thing called sum or difference of cubes. That we'll learn about. When we go to higher degree polynomials, we'll talk about sums and differences of cubes and how to factor those. But those 2 things, if there are 2 terms, most of the time right now it's going to be differences of squares. Later on we're going to get to sums and differences of cubes as an option as well. So we're going to first get the equation equal to 0. Once it's equal to 0, that opens up factoring and this thing called the zero product property. The zero product property basically says when you say x times y is equal to 0, then one of those has to be 0. If you multiply 2 things together and get 0 as an answer, at least one of them is 0, right? Has to be mathematically. But what we're going to do is, because there's going to be a variable in each factor, we're going to take the worst case scenario is that both of them are, both of those factors might be 0. Okay, so that because we don't know what the variable could be out of that, because it's a variable. We're trying to solve for that. So zero product property allows us to factor and then take those factors and set them equal to 0 to solve. So that's what we're going to be doing as we're solving these. Same thing you did in Algebra 1. So we're going to solve by factoring, and we'll work our way through solving quadratics in several different ways. Factoring is just the first one we're going to talk about. We'll get to square roots very soon, and then quadratic formulas involved with that. And so there's a lot of different ways to solve a quadratic. Factoring is a great way to solve if it works, and most of the part, and we're going to take this, and the idea is that if we could factor quadratics, we're going to higher degree polynomials like x cubed, x to the 4th, x to the 5th. We're going to be able to use factoring and using those and break those down into smaller polynomials and get answers. So the whole basis of why we're going back through quadratics, even though you've already done it in Algebra 1, is that we're going to use that when we do higher degree polynomials in here. So we want to make sure you got a firm foundation in that stuff. So first example for solving by factoring, let's start with something like this. 5x squared minus 17x is equal to negative 6. So that's a quadratic for sure, because it's got the highest part of it is got x squared in it. So we want to try to do that. Turn the phone off. Down. No. Say it again. Don't be listening to your phone while I'm teaching. No, or anything else. No sense in that. All right. Now, got a quadratic. We need to get it equal to what before we even think about doing anything else? 0. So if we see an equal sign in there, we're going to solve that. We got to get it equal to 0 before we do anything else. Now, as we learn more and more methods for solving quadratics, we're going to learn there are certain times you want it equal to 0. Other times you don't want it equal to 0. So when you're factoring, if it says solve by factoring, you've got to have it equal to 0. No question, okay? So when we rewrite that, we add 6 to get it over there. What order do we write the answer in over here? Descending order every time. So if there's a like term, we're going to combine them. If there's not a like term, we're going to put the pieces in the right order. So start with your highest exponent and go down. We're going to follow that rule all the way through higher degree polynomials. When we get to do x to the 5th power stuff, we're going to do the same thing. Okay? So descending order all the way across. Sometimes you may have to shift some stuff around, just keep the sign with it. Okay, so here we moved the 6. It was a plus 6 or positive 6, so that's why it's plus 6 there. Okay, next thing to do is go through your rules of factoring. So the first one you look for is what? Descending order, and then greatest common factor. 5, 17, and 6 have anything in common? No. So the next thing is count the terms. How many terms are on the left side there? 3. So that tells me to use what method? That X method. So this is exactly the same thing we did Friday and what you guys got extra practice on yesterday. Okay, so this is nothing new up to this point other than getting 0 on one side. That's the only thing we've added here. So what goes on the top of the X? 30. Where's that 30 coming from? There's not a 30 in that problem. It's always the front number times the constant on the end. So 5 times 6 is 30. We need it to add to be negative 17. So we need it to multiply this 30 on the top and add to be negative 17. Negative 15, negative 2. Very good. That is exactly the right two numbers. Now, can I go take a shortcut on my factoring? When can I? Yeah, if there's a 1 in front of x squared, that allows me to take a shortcut. Because there's something else there, I've got to do this the grouping way of doing things. So I'm going to take 5x squared, and then I'm going to put minus 15x minus 2x plus 6. And that thing is still equal to 0. So I'm not losing the equal to 0 part. I haven't done anything with that yet. Does it matter what order I put this stuff in the middle? No. Technically, no, but it makes sense, though, to put the 15 with the 5, right? And the 2 with the 6. It seems like that makes sense to go together. All right. Next thing to do is now we've created this problem that's got 4 terms because we split the middle one into 2 pieces. So we're going to group the first 2 together. What's the GCF of 5x squared and negative 15x? 5x. Good job. What's left in the parentheses for that one? Good job. And then negative comes out with the GCF of 2. Remember, whatever the sign is of this middle term right here, that's going to be the sign that stays right there. So if that's a plus, this will be a plus. That's a minus, this will be a minus every time. It's the same. And then what's that going to leave in those parentheses? That matching parentheses, if everything's working right and factoring works, then when you pull a GCF out here, these two parentheses are going to match. Don't just automatically copy that over. You've got to look at it and make sure that as you pull out that GCF that it actually does that. Then the factored form of that, this is all still the same thing we did Friday and yesterday so far. So we've got the matching piece and then the stuff in front. Those are your two factors. First factor, the matching stuff, the stuff in front makes up the second factor. Now, zero product property tells us when you've got two things, got x minus 3 is one thing, 5x minus 2 is a second thing. We got two things that are multiplied together, that at least one of them is 0. Well, they both have a variable in there. So we think, okay, it could be either of those that's 0. We don't know which one it is. So we're going to take the worst case scenario and set them both equal to 0, find out what x could be. Okay, so we take x minus 3 equals 0, 5x minus 2 equals 0. Get x by itself on those individually. That's all we're doing. So this one, quick one move, add 3. X is equal to positive 3. Okay, second one, it's 2 steps. Add 2, 5x equals 2, divide by 5, 2/5. If x is 3, that problem equals 0. We plug a 3 in right here, 3 minus 3 is 0. That part equals 0. 0 times anything over here is going to give me 0. So that's why 3 works. 2 over 5, if I plug that in on this one, 5 times 2 over 5 is 2. 2 minus 2 is 0. That means whatever this ends up being times 0 is 0. So that's why we got two different answers. If you take those two answers and go back to the original problem and plug them in one at a time. So if I plug in the 3 to the original problem, 3 squared is 9 times 5, and then 17 times 3. So 9 times 5 is 45. 17 times 3 is 51. So 45 minus 51 is negative 6. It works. If I do the same thing for the 2/5, I'm going to square 2/5, which would be 4 over 25 times 5 would be 4 over 5. And then 2/5 times negative 17 be negative 17 times 2 will be 34. And so negative 34 over 5 plus 4 over 5 is negative 30 over 5, which is negative 6. So it works we can check that by going back to the original and just evaluating the expression out of that. So same thing you did in Algebra 1. It's nothing new there, but just kind of trying to reinforce that idea and make sure that we know how to do that. Because when we get to bigger polynomials, if you can't do the quadratics, you're kind of stuck, with only getting part of the way done. So let's look at this one. X squared plus 12 is equal to negative 8x. So a similar problem, just a few key differences. What we do first? Move the 8x. Technically, could I move the x squared and the 12? I could. It'd be a lot more work, though. It'd be doing two things instead of just one, right? So it doesn't matter which side you get the 0 on. Just make sure, just go to the easiest route. And a lot of times the easiest route includes keeping that x squared term positive. If you can keep the x squared term positive or make it positive, then it is much easier to do your factoring. So why did I put that kind of in the middle there? Yeah, because when we put it in descending order, it's going to be in the middle anyway, right? So plus 8x plus 12 is equal to 0. And then we look for a GCF. 8 and 12 have 4 in common, but the x in the front doesn't have anything, right? So we can't use 4 as a GCF. So there's not a GCF for this one. So the next thing to do is what? X method, because it's got 3 terms. What goes on the top of this X? 12, got to add to be 8. 6 and 2. 6 times 2 is 12. 6 plus 2 is 8. So we got the right 2 things. Can I take a shortcut with this one? Yes, there's a 1 in front of x squared, so that means it's got a shortcut to it. What is the shortcut is to take the 2 factors and whatever there are in our x, that's a positive 6 and a positive 2, so that's a plus 6, and this is a plus 2, and then it's just x in the front. And well, that's the factored form. We won't solve it. So how do we solve that then? Set each factor equal to 0 and just solve. So x plus 6 equals 0, x plus 2 equals 0. We know that's really easy math. -6 and -2. Super easy on when it comes to that. We can take that shortcut on the factoring. That speeds us up a lot, makes the solving even easier as well. Okay, so here we have factored form. That's going to be important later on when we start talking about graphs and things like that. So this is what, if I say factored form or intercept form, that's what that is. But these are actually our solutions. When we start referring to graphs, these will be our x-intercepts. So kind of start thinking about that as we go along here. Not doing any graphs right now, but we're going to get there eventually. So 4x squared minus 5 is equal to 4. Four x squared minus 5 is equal to 4. Seems easy enough. This one technically has more than one way to solve it, and you probably know that other way, but let's practice factoring on this one instead of doing, if you're thinking move the 5 and do square roots, that works, but I want to practice factoring here. So let's move the 4 and get it equal to what? 0, so that we can use factoring. Be 4x squared minus 9 is equal to 0. We look for a GCF. 9 and 4, do they have anything in common? No. So difference of squares is what we're going to try. How do I know to try that? 2 terms and what sign in the middle? A minus sign in the middle. So I'm going to try to rewrite the problem as a difference of squares. So something squared minus something squared. What squared gets me 4? 2, and I need an x to get x squared. So that'll be a 2x. What squared gets me the 9? 3. Because I can rewrite it that way, my factors are really easy. I can take that little shortcut. 2x in the front, 3 in the back. One's a plus, one's a minus. Doesn't matter which one you put a plus and minus to. But if we can rewrite it that way, then the factors work that easy. Okay? Set each of those equal to 0. And solve. Subtract 3. Divide by 2. Get this fraction. -3/2. Leave it as a fraction. Don't convert that to a mixed number or a decimal. Leave it as a fraction. Same thing over here. Just going to change signs on us. It's the +3/2. So main focus of today's stuff is solving by factoring. As we add the other methods that you probably already know into that, then you get those options about solving one with that. But just want to try to focus on factoring today. Let's look at this one. 3x squared equals -12x. This is a simpler one, but a lot of times the simpler ones we forget what to do just because we get so used to X method and other, and the differences of squares and things. So what do we need to do with this one? Get it equal to 0. So a couple different options. We can move the 3x squared or we can move the negative 12x. I'll always try to look at the leading term, the one with the highest exponent, and keep it positive. Is 3x squared already positive? Yes, I'm not going to move it. If it were a negative 3x squared, I'd probably move it to the other side just to make it positive. So if you'll keep that first term positive, the factoring is so much easier because you don't have to worry about the negative sign as much. So I'm going to move the 12x by addition. And there's my equal 0, and put it in descending order. So 3x squared plus 12x. And now what? What is the greatest common factor? 3x. What's that leave in the parentheses? X plus 4. Will the stuff that's in parentheses factor any further? No. Always look for those things. If it will factor further, then do it. But this one doesn't, so we're going to take these two factors and set them equal to 0. This 3x, it's got a variable, so it's going to have an answer. If your GCF is just a plain number, then you're not going to have an answer for that one because a plain number never can equal 0, right? Okay, so we're setting 3x equal to 0, x plus 4 equal to 0, get x equals 0, x equals negative 4. Those two solutions there. Easy one-steppers when you do that. So easy stuff there. All right, let's look at one that's more difficult. 3x squared plus 10x minus 300 equals 15 minus 2x squared. That looks rather large. We can make it a little smaller. So what would our first step be? Get it equal to 0, absolutely. So what am I going to do to get it equal to 0? If I subtract 15, that'll get rid of that piece. And then what about the negative 2x squared? How can I get rid of it? Add 2x squared, and I'm just going to add it to its like term. So that's going to give us 5x squared plus 10x minus 315. Now it's equal to 0. So that helps us. Now what? Greatest common factor, which would be what? 5. 5 goes into itself. 10 and 315. So we pull out a 5. X squared plus 2x minus 63. Is that right? Okay. Now what? X method on this stuff that's left in here because there's 3 terms in there, right? So we're going to do X method on the x squared plus 2x minus 63. So that's a negative 63 up top, a 2 in the bottom. We're looking for 2 numbers that multiply to be negative 63 and add to be 2. 9 times negative 7, very good. Positive 9 and negative 7. Can I take the shortcut to factor this? Yes. This 5 is not part of that anymore. It's just hanging outside. So there's a 1 in front of x squared. So that allows me to take that shortcut and say that is x plus 9 and x minus 7. The 5 is still there technically. What happens to this 5? We don't want to distribute because that ends up undoing what we've already done. Mathematically, you could do that, but like I said, it undoes what you've already done. So we don't want to do that. If we divide by 5, because what's going on over here is you're saying 5 times some other stuff. So technically, the math thing that happens to get rid of that is to divide by 5. What do we know about 0 divided by a number? It's still 0. So we know that this thing is just going to be x minus 7 and x plus 9 is equal to 0. So that constant that's out in front, because it doesn't have a variable, you can just know it cancels out and goes away. Okay, so that extra step there, I would definitely just do in my head and say, okay, I don't have to worry about that 5 anymore because it doesn't have a variable in it with it. And then we've got these two things left, and that's an easy solve. X plus 9 equals 0. X minus 7 equals 0. We know those answers are x equals negative 9 and x equals 7. So all of this factoring stuff that we're doing, once we get it equal to 0, is exactly what you've been doing the last couple of days. We're just adding the solving step to it today, which is really not bad. Let's do another one here. Let's say negative 2x squared minus 3x is equal to 3x squared minus 20x plus 6. So similar problem to the previous example, just a little different. Which side is the heaviest? The right side. It's got 3 terms on it. The left side's only got 2. So the shortest way to get it equal to 0 would be moving which ones? All the stuff that's on the left side. Okay. I also know that in order to move that negative 2x squared, what do I have to do? To get rid of this, what do I do? I add it back. And that's going to give me what in front of x squared? A positive number, right? And that's what we want. Anytime our leading term, we want to be a positive coefficient, if at all possible. Okay? So that makes the factoring easier. So I'm going to add 2x squared. And then how do I move the 3x? Add 3x. So I'm just doing that all in one step. And I definitely think we're all at a level where we can do that. Algebra 1, we probably would say you got to write individual steps for that. I don't think we need to do that. Algebra 2, you guys can do that. You can text and drive. I mean, no, you wouldn't do that. 5x squared, and then negative 20 plus 3x would be negative 17x, and then the 6 is still the same. So even though the 0 is on the left side, does that change the factoring? No, it's still the same thing. If it bothers you that the 0 is on the left side, just move it to the right side, and it's okay. It doesn't matter, okay? Doesn't matter which side the 0 is on. The factoring is still the same. So what do we do for that one? The x method. What goes on the top? 30, and then negative 17 on the bottom. Negative 15 and negative 2. And then 5x squared minus 15x minus 2x plus 6. So I'm replacing the middle term with the things for my x. Group. GCF of that first group. 5x. What's it leave in parentheses? X minus 3. Second group. Negative 2. X minus 3. So we have x minus 3, 5x minus 2, and then we set each of those equal to 0. remember, if somebody asks you for the factored form, this line right here is the factored form. Okay, so make sure you know that part. And then we're just setting each of those factors equal to 0 and getting x by itself. 3, and then this one you'd add 2, 5x equals 2, and then divide by 5, so x is equal to 2/5. So solving by factoring, get it equal to 0 first, and then it's exactly the same thing as what we did Friday. So if you missed Friday, the factoring part's no different than what we've talked about today. So that'll help catch you up with that part. The only thing we're adding today is set them equal to 0. Once you get there, get what x is equal to. You can always check your answers since we're dealing with equations. Take your answers, plug them back into the original, see if they work. If they don't, then something went wrong, either in your solving or in your finish, when you're actually plugging them back in. Okay? All right. Do some paper stuff today. Go from there.